In the previous video, we showed how to extract some peak flows. The peak flows are necessary because we want to determine if the crossings, the bridge or culvert we are going to build can carry those peak flows. So in this video, we are going to set up a 1D steady flow data in a HECRAS, and we're going to populate that with information. For this video, I have determined the peak flow for my crossing, and I'm going to use this peak flow for the different profiles to see. This is in cubic feet per second, and this is the peak flow for the 2 years, 5 years, 10 years, 25 years, 50 and 100-year return period. And to be able to build it, I need to go back to my HECRAS, and I can close my geometry at this point. Save geometry data, close geometry, and did I have it? Yep. So I can save. I'm going to edit steady flow data, and I can say file, save flow data as, and I can call it my stream flow data, stream peak flow. And I can hit OK, and then the description will be peak flow for my test site, covered model. And with that, I can hit apply, and I want the river is the West River, the reach is the West Reach, and I have 6 profile as I'm showing below. So I'm going to enter 6, and I hit apply. So I need to change the profile to match my return period. So I can say options. I will say the F5, and let me say option, edit profile names, so that we come down here. So this will become 2 year, and then this will be 5 year, and this will be 10 year, and this will be 25 year, 50 year, 100 year. Okay, and then I have to insert the value, so I have 216. So what is happening is the flow data have chosen the first cross section at the top as where the flow is going to be inserted. If we want, we can add multiple cross sections. So we just need to go here, options, and say, see, observe. We come to add multiple, and we can do select all of them and say okay. So that adds all the cross sections. That then we can add individual cross sections. So basically what we are saying is if you go here, for every cross section here, we are assigning individual flow. If we have for a complex model where we have changes, information of the queues, the peak flow at each cross section, it is fine, we can use that. But the most appropriate or basic way is to use the peak flow for contributing to this watershed, and let it start from the top and let it route down so we can see the changes as the water flow from top down to the last cross section. So to do that, we don't need all this cross section, so we have to right click and hit option, delete from row, delete row from table, delete row from table. We're just going to leave the first cross section, which is the, let me see, delete row from table. delete row from table, delete row from table, delete row from table, delete row from table. So we are going to have 216 for the 2 year, for the 5 year, 345, for the 10 year, 478, for the 25 year, 781, for the 50 year, 955, for the 100 year, 1200, 100. How to cross check, make sure there are no problems. 781, 478, 345, 216. So I'm going to hit apply data and say file, save flow data. But we need to also take care of the boundary conditions. So if I click that, we need to know the boundary condition upstream and downstream. If we have a known water source elevation, we can click here and enter the water source elevation for each of the flow. But we don't know because we are building the model from new. We don't have an existing model that we are copying from. So I'm going to cancel this. We are going to use the normal depth. And to get the normal depth, we can go back to the cross section editor and we can pick the first cross section, and we need to hold control, pick the first point and pick the last point in the cross section, and we can see the change. This is the change, the dy dx. So we use that value, we go back to our editor, and that's for the upstream. So boundary condition, the upstream is normal depth, so we're going to add the slope depth computation for the ridge. So we'll say okay. For the downstream, we're going to pick here and edit cross sections. I'm going to close this, hold this. I want to use this. I change, I close this, and I close this. No, with normal depth, not critical depth. Let's see. Delete. So we'll go to normal depth. I'm gonna put it here. I hit OK. So if we go back, we can see our boundary condition for upstream and downstream. So we'll hit save. So I'm going to file, save flow data as, or rather not save flow data as. So if we've done that, just say file and save flow data. So that update as needed. So I'm going to close this. I'll save my file. So now we have the stream peak flow, and that is how we set up the 1D the steady flow data, and having 6 profiles and also having the boundary conditions that we need. And now we are ready to run the model. So I'm going to hit save and I'm going to exit. I will see you in the next video where we run the model.